Hey everyone, so this is a follow-up video to my last video, which was about bottle cap detection. And I have followed up on this video because we are now in a separate phase where we want to test this sensor on the line. But remember, we have two different types of bottle pills coming down the line, which is they're both identified through a blue puck and a white puck, which is like the holder for the bottles. So we are going to need a sensor that differentiates the two of them. So in this setup, just to introduce you here to my hardware setup, I have my color sensor, the QCM50, down on my bottom right, and it's looking at that blue target. And so that's just for demo purposes here, different bottles, two different bottles, different sizes, and the targets that we wanted. And so I have each target tied to a separate output on that sensor. I really enjoyed working with the QCM50 because I used it over IO Link. If you can see how it's connected there to my remote IO block, which is a IO Link master. And I was able to get all sorts of really cool information. I was able to teach the sensor remotely and do a lot of really cool things through the IO Link side of it. And then I have my LM150 sensor, which I talked about in my last video, high resolution, so 0.001 millimeters, and it's looking down to the flat surface of that bottle, and it's on the top right of my video here in my setup. Maybe this might be easier to see. So you see the red dot is coming down on that bottle cap, and it's making sure that it is seated all the way. So as you can see, my two sensors are connected to port 1 and 2 of my IO Link master, and I have an output of all of this information going over Ethernet to my user interface, my HMI. Really, the use of this HMI is just to show some settings and troubleshooting support for them to see what's going on. Okay, let me demonstrate this to you. So I'm going to walk over there and show you exactly how it is supposed to work. So here is my resolution, high resolution LM150 sensor, my color sensor, my bottles, my IO Link master, HMI. So I have presented a blue bottle and I have an output that says it's there, I see it, that it's blue, I'm giving you an output. I have a sensor that is directly looking down on it. So we're gonna go here into our HMI and click on the blue puck view. So we have some settings in here already. So if I seat this all the way down, this is gonna be my fully seated max set point. So we see the measurement should be about 72. So we're going to put this at 72.05, is that what it was? So anything above that, maybe we want to give it just a little bit of wiggle room. So 72.0, how about that? Oops, a little bit more, the other way, 72.1. Maybe that might be too much, but that's for us to play around with. So the not seated condition. So we're going to look at that setting. So we're going to position the cap. Where is a good best worst case scenario? So right here for me seems to be like a good threshold. So we see it's 71.2. So we're going to set this to 71.2. So we're going to start, that's a good starting point. Right now it sees it as okay, but if I go just a little bit more, we see that we are at different places here. So it takes a little bit to tune up, fine tune, running it down the line and seeing exactly what's going to be a bad condition. But this sensor gives us that ability. So right now, if I pick it up and I throw it the other way, it's going to be okay, even though it's not fully seated. We can tighten that up, but that is up to the supervisor and the controls engineers how they want to handle that, but this will handle the logic. So we go back here to our white now, and we can set it up in a similar way. So that is pretty much it on the hardware demo. So let's get into the database so you see exactly how the logic works in case you need to get in there and, kind of look around. Let's take a look under the hood. It's nice to have a user interface with it. So let's get to the point here where we look at the Crimson software, which is the software for the HMI programming. So let's look at our database here just for you to see. It's a very simple setup. Again, the scope of this project is just to be able to set the window measurements of each device, some information, and your full layout here. We have the IP address of both devices. We have each IO link port, what should be connected to them. On our communication side, we have our Ethernet communication set up to Modbus TCP. Here's our IO link master. There's the IP address for that master. And then under tags, I have labeled everything here. So each folder is each device with the information that I actually need. We've got here a numeric tag for measurement. I had to do a little bit of shifting on the bits. That's how it is with IO-Link. If you know IO-Link, you have to do some bit shifting sometimes and masking and that kind of fun stuff. And I'm just looking here at some bits and our channel 1 output state. So that's the LM150. On the color sensor, I'm literally just taking the two outputs that I have programmed, and I'm looking at that process data and taking those bits. That's all I'm doing. It's very simple, straightforward. And then I'm turning on two different outputs on my IO-Link master. So if you know IO-Link, you can use it for IO-Link devices, but not necessarily. You can use them as a discrete input or a discrete output. So I've chosen here to maximize my use of this device, and I'm using my outputs for port 3 and port 4 each. So those are set up here accordingly. You'll notice that they are set up in different registers, and I'll show you how to turn those on as well. Here are some internal tags that I used in my programming in my logic. Now, speaking of my programming, here is my program setup. So we have the ability to do some C-style program. And if you, again, want this database, I'm super happy to email it to you. Just send me an email. All my information is in the description box below. You do have to translate your program here up with the green check mark. And I'm running a very simple program, just very basic if, then, else, some ands and ors, and greater than or equal to comparisons here. Getting the measurement, if it's greater than the set point or less than the set point, then I'm throwing up a flag. If not, set it back to 0. And then I am making sure that if it's a blue and it's out of range, then I'm getting an output. So turning on your port on your IO-Link master, at least with Banner Engineering Masters, you have to enable the port and then set another bit to turn the discrete on. So that is a decimal value of 3, else 0. And so I've done that for both the white and the blue. So you're welcome to, this is a good program to just kind of look at and take a look around. And if you've never used IO-Link, it can help you get started on something. On my web server, I just have it enabled to do remote control so I can take a look and look around. I usually set this up to HTTP so that I don't have issues with HTTPS. And to show you my display settings, this is where I created my displays, my windows. Everything is set up here. I try to make it look nice. I do have to clean this up and take it out for my customer. And you want to make sure that if you make programs, you are actually calling them. And for Crimson devices, we use the on tick, which is like once a second. And so that is going to give us a call on our program once a second. And if that is good for your application, then that works. And we just flash it. And we can be off to the races. So this is the setup for my demo for the proof of concept. I hope that it works out great. And if you have any questions, let me know. We have HMI classes on Crimson at least once a month in the Dallas and the Houston areas. If you want more information, contact me below and I will get to you as fast as I can. God bless.